All right, so in this example, we're being asked to solve the following third-order linear ordinary differential equation with the given initial values. All right, so here's our third-order linear ordinary differential equation, and these are the initial values for the equation we're trying to solve. Now, there's going to be a lot of steps here, so I want to outline everything that we're going to need to do in order for us to be able to solve this. The first thing we're going to need to do is take this differential equation and turn it into an auxiliary equation. And since this is the third order, that means the auxiliary equation will be of degree 3, which likely means we're not going to be able to factor. So we're going to use synthetic division to take that auxiliary equation to get the solutions. Then, with the solutions of the auxiliary equation, we're going to be able to create the general solution for the third order linear ordinary differential equation, but we won't know the constants. We're going to have three constants we don't know. So then we're going to take these initial values and plug them in to the general solution, and it's going to create three sets of equations because we have three initial values. And once we have three equations and three unknowns, we're then going to create an augmented matrix, and we're going to use matrix operations to solve that for us. We could do it by hand, but it's a lot of work. So we're going to use the calculator to do that for us. And then finally, we will get the values for the constants that we don't know, and we'll be able to plug that into the general solution, and it becomes the exact solution to the third order linear ordinary differential equation. Okay, there's a lot there. So let's get started. The first thing we're going to need to do is turn this third order diffeq into its auxiliary equation. So that would mean m cubed minus 6m squared plus 11m minus 6 equals 0. All right, once again, as I pointed out earlier, because this is of degree 3, it's not going to be easily factorable. So what we're going to need to do is use synthetic division to help us break this down. So first off, here is P and Q is understood to be 1. So our possible choices for P's over Q's is going to be plus or minus the factors of this guy, 1, 2, 3, and 6, all over this guy, which is 1. So that's not too bad. So I'm going to go ahead and create the coefficient list here. 1, negative 6, 11, and negative 6. Okay. So from my list of possible zeros, I'm just going to start right at the beginning with positive 1. So I'm going to use that as my first choice, and hopefully I get lucky. So bring down the 1. 1 times 1 will give me 1. Negative 6 and 1 will give me negative 5. Negative 5 and 1 will give me negative 5. The difference of that will give me 6. 6 times 1 is 6. And then this difference is 0. So I got lucky. Right away, I'm able to actually find my first 0, which means I have my first factor. Remember, this is always your remainder, your constant, your x, and your x squared. Generally speaking, for synthetic division, when I create the next step in the auxiliary equation as it's factored, I'm going to switch it back to m, just so you're not confused. But generally speaking, through synthetic division, it goes remainder, constant, x, and x squared. Okay, so where are we? Well, if 1 is a 0, that means m minus 1 is a factor. Okay, what do you have left? Well, you have m squared minus 5m plus 6. So here we go. M squared minus 5m plus 6. Now, once again, remember, I know it says x squared and x. The original auxiliary equation had m, so that's why I'm going back to that. All right, well, this is quadratic, which means hopefully it's factorable. Now that we've gotten the synthetic division out of the way, this is manageable. So m minus 1, and indeed it is factorable. If you look, factors of 6 that make a negative 5, you're looking at negative 2 and negative 3. All right, so after all that work, we now get the solution to our auxiliary equation, or the solutions, plural, of m equals 1, m equals 2, and m equals 3. All right, what do we do with that? Well, we are going to go ahead and write the following situation. Y is equal to, I'm going to leave some parts out right away, but then put them back in, e to the 1x plus e to the 2x plus, oops, I need some space here, e to the 3x. So, solution 1 goes here, solution 2 goes here, solution 3 goes there. But this is the general solution, which means we don't know those constants. So this is C1, C2, and let me get some space over here. This will be C3. Okay, so let's recap where we are so far, because we're really just about halfway there. Still got some more work to do. Here is our third order linear ordinary differential equation. We created our auxiliary equation from that. Because it was of degree 3, we needed to use some synthetic division to help us break it down. We got lucky right away. Our factor m minus 1 we found. And then this broke down further. So our solutions became 1, 2, and 3. Here is our general solution to the original equation it was asking. But because we have initial values, that is going to be the next step. We're going to create 3 equations with 3 unknowns, C1, C2, C3, based on the initial values. So, scenario where the input is 0 and the output is 21 will look like this. C1 e to the 1 times 0, because that's our input, plus C2 e to the 2 times 0, plus C3 e to the 3 times 0. Okay. Well, if you plug in 0 for all of these, e to the 0 becomes 1. All you're left with is C1 plus C2 plus C3. So this is C1 plus C2 plus C3 equals, well, if the input is 0 according to the initial value, then the output is 21. All right. That is our first equation. We've got 2 more to go. When we plug in 1, we get C1 e to the 1 times 1 plus C2 e to the 2 times 1 plus C3 e to the 3 times 1. And that is going to result in C1 e, because 1 times 1 is 1, plus C2 e squared plus C3 e to the third. And that output value is all of this stuff. So for now, what I'm going to do is just draw an arrow. In a little bit, I'll clean it up. But for now, I'm going to save some time. That is equal to what goes right there. Okay? And then our third equation, when we plug in 2 to the initial value, we get C1 e to the 1 times 2, that's our input, plus C2 e to the 2 times 2, plus C3 e to the 3 times 2. Cleaning that up, it looks like we get C1 e cubed plus C2 e to the 4th plus C3 e to the 6th. When we plug in the input, the output becomes this guy. So again, for the sake of time, I'm just going to go ahead and draw that arrow. All right, so a quick recap before we jump into the next step. We had initial values that we plugged into our general solution, and it allowed us to create, because remember our general solution, we didn't know this constant, or that constant. It allowed us to create 3 equations for 3 unknowns. If we have 3 equations and 3 unknowns, we can then turn this into an augmented matrix and then go ahead and solve it from there. That is what I'm going to do next, but I'm going to need to clear all this out. So I'm going to go ahead and do that and then rewrite this nicer part, or clean this up and rewrite that. So I'm going to go ahead and do that right now. Okay, let's go ahead and write our cleaned up equation. So we have C1 plus C2 plus C3 is equal to, I'm going to do all the constants in yellow. So that is equal to 21. Okay. Then we have C1 plus C2 plus C3 is equal to, once again, constants will be in yellow. So this is C1e. This is C1e squared. And this is C1e to the third. And that results in this output of 3 times e squared plus 2e plus 4e to the third. Okay? And once again, we have our unknown constants. Okay? And this is e squared, e to the fourth, e to the sixth, and then finally we have this output, 3 times e to the fourth plus 2e squared plus 4e to the sixth. Okay, so here we have 3 equations, 1, 2, 3, with 3 unknowns. So what I'm going to do is I'm going to utilize the TI calculator to help me solve this. First, what I'm going to do really quickly is point out these guys have constant coefficients as well, 1, 1, and 1, just so it's absolutely clear where I'm getting all of my values when I create my matrix. So I'm going to go ahead and create that matrix. It's going to be a 3x4 augmented matrix. Let me get a little bit more space here, mostly because these parts are a little bit long, so I need some space for them. All right, and here we go. It's going to be a 1, 1, 1, and 21. It's going to be an e squared, and e to the third, and then all this, e squared plus 2e plus 4e to the third. And then I'm going to have e squared, e to the fourth, e to the sixth, and then this guy, 3e to the fourth plus 2e squared plus 4e to the sixth. All right, let's go ahead and plug in this guy into our calculator. Remember, again, it is a 3x4. So I'm going to turn on my calculator and go to the matrix option. So I'll hit second matrix. I need to create the matrix, so I'm going to go over to edit, hit enter, and then again it is a 3 enter by 4 enter. That's 3 rows and 4 columns. So we're going to go ahead and put in all of these values. So we have 1 in the first spot, then 1 there, then 1 there, and then the result of that is 21. Notice when I hit enter, it will now jump down to this location. That value is simply e, so plug that in. Okay, the next one is e squared, so I will do e to the power of 2. There's different ways to do it on the calculator, but that's what I'm going to do. And then I have e to the third, second e to the power of 3. And then finally all this fun stuff, that will be 3, open parentheses, second e squared. Make sure if I have to write something after a power, I hit to the right, so I drop back down. Where are we? Plus 2e plus 4e to the power of 3. I'm going to jump down and then close that guy. Now notice here it's a big ugly mess, but as soon as I hit enter, because E is a constant, it'll actually calculate that for me. There it is. And then now I'm going to do the last row here. I have an E squared. I have an E to the fourth, E to the power of 4. Cool. And then I have an E to the power of 6. And then I have that fun stuff, 3 open parentheses, E to the fourth, drop down, plus 2 E squared, drop down, plus 4 E to the sixth, drop down, close. Once again, even though I have a big ugly mess, when I hit enter, it'll calculate the constant for us. Okay, so the calculator now knows this augmented matrix. What I'm going to do next is turn this into reduced row echelon form, and the reason I want that is because it will give me all of the solutions that I'm looking for, namely the values for the constants that we don't know. So when I go ahead and do this next part, I'm going to actually get what I want here, here, and here. All right, so let's do that. So what I need to do is I need to go to the home menu, so I'll hit second quit, and I need to access a matrix operation. So I'm going to do second matrix. I'm going to go to the middle column, so just go over 1 unit, and I'm going to go down until I see RREF. It's abbreviated for reduced row echelon form. So be careful, not REF, I want RREF, reduced row echelon form. I'll hit enter. So I've got this on my home screen. I'll now want to tell it to do this operation to our matrix A. So I go second matrix. A is the default that's there. I go ahead and hit enter. I will close parentheses. So what we're about to have happen is this matrix, which is a 3x4, we're going to have it reduced into this format. And what that will do is it'll tell me the value for C1, the value for C2, and the value for C3. So I'll go ahead and enter, and there we go. The value, the mystery value for C1 was 6, the mystery value for C2 is 3, and the mystery value for C3 is 12. Take a deep breath. Okay, so what can we do? We can finally put together the solution to the third order linear ordinary differential equation, including the constant coefficients because we had initial values. Okay, so let's go ahead and do that. So if you recall, the general solution was the following: C1 e to the x plus C2 e to the 2x plus C3 e to the 3x. But we now know C1, C2, and C3. So the actual equation, I'm going to leave out the constants in a second and put them in the end. Even the markers are excited to get the problem over with. 6, 3, and 12. All right. So let's recap what this final answer is. We had a third order linear ordinary differential equation with some initial values. We needed to turn this equation into an auxiliary so we can find this general the solution to the auxiliary equation were the values up here, so we can come up with a general equation in terms of C1, C2, C3. We then plugged in our initial value problems, or values, and the corresponding outputs, and that gave us a series of equations, but we still didn't know C1, C2, and C3. We had 3 equations with 3 unknowns, turned that into a matrix, specifically an augmented one. We then used reduced row echelon form with the help of our handy calculator, and it gave us the values for C1, C2, and C3, which means we were able to figure out the actual equation, including the values for C1, C2, and C3.